So, first of all, yesterday was formulas, naming and formulas for ionic compounds.
Are these diamontic hydrogen?
We wanted Lewis diagrams, so no. Lewis diagrams are like these. You draw the lines for the sharing ones. This is, that's a Bohr diagram.
And for this one, you replace this thing with the line?
Yeah. Yeah. Okay, so there were some questions about the homework, so let's go over those first. Perhaps it would be helpful to give you guys the answers for these things. Before I do that, Evelyn, did you want to go over any one of these in particular? Potassium sulfide. So let's do that. Yeah. Okay. You don't have to avoid crossing over. You can do it that way. It is a totally valid method. So, but I'll show you, I can show you the longer way. So potassium sulfide, we're starting with potassium and sulfur. Potassium's got a charge of, if I look up at the table, -3. And sulfur's got a charge of, potassium. Come on, Dweedoff. That was me modeling a classic mistake. Potassium's not P. Potassium is K. So this will be Ks. Sulfur is -2. I had two people sneak in. That was Olivia. Yes. Olivia, would you like your Bohr diagram, Lewis diagram assignment back from Monday based on the stuff that we did yesterday? Okay. So Olivia's here. And let's see is here. Okay, so K. K has a charge of +1. So the kind of longer mathy way that I showed you how to do this yesterday was to say, okay, well, if I've got a charge of +1 and I've got a charge of -2, I need to find the smallest number that both of these go into. The smallest number that 1 and 2 both go into is 2. So I need to bring enough so that my K's are +2 and my S's are -2. Angel, is that you? Angel's here, Sue. Okay, so how many +1s do I need to bring so that I have 2 of them? 2 total. +2. Yeah, I need to bring 2. 2 +1s is going to give me +2. And how many -2s do I have to bring so that I have -2? I just need to bring one of them. So 2 1s is going to give me 2. 1 -2 is going to give me -2. And now these two are balanced. So then my final formula here is just going to be K2S, because we don't write, wherever there's a 1, we don't write it. Evelyn, did that make sense? Okay, let's do another one. It will click. We'll make it click. Aluminum and, no, let's not do aluminum and chlorine. Let's do magnesium and nitrogen. So magnesium nitride is going to be Mg with a charge of +2 and nitrogen with a charge of -3. So this is, we need to, if you're going to do it the long way, swap and drop, we just put the 2, bring the 2 down, bring the 3 down. But the longer way to think about it is, what's the smallest number that 2 and 3 go into? Not that goes into them, but the smallest number that 2 and 3 both go up into. 6. So I put that number down here at the bottom. This one's going to be +6. This one's going to be -6. And then how many +2s do I need to give me 6? I need 3 of those. And then how many -3s do I need to give me 6? 2 of them. So then my final formula is going to be Mg3N2. So then the rest of these answers, I'll just crank them out for you. I have them here somewhere. This one's going to be NaCl. This one's going to be Zn3P2. This one's going to be CaBr2. AlCl3, Li2O, and CaS. Those are the answers to the 8 questions I left you with yesterday. Comments, questions, concerns? Who just snuck in? Kaylee just snuck in. Okay. So Olivia said she wants hers back. Katie, would you like your or Lewis assignment back based on the stuff you did? You're happy with it? Yes, you're right. You're happy with it. Yours. Okay, so then if I have not offered yours back, I don't have one from you. So I need that I would like that Bora Lewis assignment completed over the weekend, given the stuff that I went over yesterday. And here we go. So today, we're going to look at the rest of all of the ionics, which should all be reviewed from stuff you did in grade 9. We're going to start with something called the multivalent metals. There are some metals that have different valence numbers. Now, a valence number is another way of saying the ion charge. So on this big table, the big table that I've given you now is a lot easier to read. If you didn't grab a big table, if you were one of the, so Kaylee, Olivia, Angel, I don't think you grabbed. On this table next to Jedediah on the front here where the hole puncher is, I have one of these big guys. If you haven't grabbed one yet, go do that. If you have grabbed one, the hole punch is there if yours doesn't have a hole punch. So when so with these numbers up here where it says ions they commonly form, we also call these numbers valence numbers. It tells you what kinds of ions these guys form. So this means they can form several different, did I spell that properly? Yeah, I did. Types of ions. So there's a ton of examples. All of them are found in, actually, yes, I shouldn't say that. The bulk of them are found in this middle section right here. There's a few down here that do this. A bunch in this, some in the bottom 2 rows do it. But almost all, I shouldn't even say that. The bulk of them, the most common ones, are going to be found in the middle of the table here. An example would be something like manganese, this guy right here, Mn. You can see up here the valence numbers are 2, 3, 4, 6, and 7. So there's 5 different kinds of ions manganese can form. So an example I'll throw here, manganese, Mn is going to be, actually I'll write out the whole name, manganese. Can be Mg plus 2, or it can be Mg plus 3, or Mg plus 4, or Mg plus 6, or Mg plus 7. All of these are valid options for manganese. And so the question becomes, how do we decipher between those different kinds of manganese ions? Because they're different. The charge that they form helps it behave or forces it to behave differently. So the properties that they form are different from each other. So we must treat them as different ions. And we can't just use the name. Another example, copper can form either Cu plus 2 or it can be Cu plus 1. And those 2 different brands of copper are different. So last year, you were taught that Roman numerals, this is where the Roman numerals come back. Roman numerals are used to distinguish between the possible ion charges. So let's do a quick review of Roman numerals. You don't need, I don't think you're going to need anything beyond the first, well, yeah, you're only going to need 8. So the Roman numeral for the number 1 is what? What's the Roman numeral for 1? It's I. The The Roman numeral for 2 is, yeah, someone said I, 2 I's. So I write them like this, just the 2 I's with the 1 bar on top, 1 bar on bottom. 3 is 3 I's. 4 is, yeah. So the Romans counted 1, 2, 3, and then they said, okay, well, that's too many. So let's go IV and introduce a new symbol. So the way they count this, well, and then let's do the next one. What's 5? 5 is V. So the way they count is, which we don't actually have to put the bars on top either. We just call it V. They say, okay, well, we go 1, 2, 3, 1 less than 5, 5. 6 is VI. So they count 1, 2, 3, 1 less than 5, 5, 1 more than 5. And then we need 7 and 8. 7 is VII, and 8 is VIII. So those are the only ones we need, because I don't think there's any ions bigger than 8. And now we have to use these in the name to decipher which ion we have. So if I have a copper +1 ion, I would call this copper, and then in brackets after it, I would put the Roman numeral I, or the Roman numeral for 1. Cu +2 is going to be copper with a Roman numeral 2. So now we just need to figure out which one we've got. When you're ready, flip the page. Okay. So, naming rules. Here we go. Just like before, and just like with all ionic compounds, the metal, or in brackets, I'll put the positive, is said first. And this is the only one that could have multiple charges. The negative ions all form only one charge, but the positive ones can give up different amounts. So this is the one that it could have multiple charges. If it does have more than one charge, the word in here is charge, we include the Roman numeral. To identify which charge is used. If it doesn't have more than one charge, you don't use Roman numerals. And we have to figure out which charge is being used. The nonmetal is given the suffix IDE, just like before, and then it doesn't matter how many of each atom there is in the compound. It will later with other compounds. So let's go ahead and name these things. So I've got Fe2O3 and I've got FeO. If you look at the periodic table, iron is one of these guys here that can form different charges. It can be either a +3 or it can be a +2, and so we have to figure out which is which. Which one shows up where. And so this is where, like, the reason I use that kind of mathy way of doing things is it's actually really helpful for what we're going to do now. So to name this thing, that Fe is going to be iron, because we've looked at the periodic table and it's got multiple charges, we need to figure out what that Roman numeral is going to be. So I'm going to put the brackets down here because we're going to fill it in with a Roman numeral. And then the O is going to become oxide. It's oxygen, but then we change the ending to IDE. And now we need to figure out what we've got. So the mathy way of building the formulas we're going to use in reverse. So I'll show you how this works. I've got Fe2O3. And we need to figure out what the charge is on Fe. What's the charge on O? -2. Okay, so I'm going to put the charge for oxygen up there. Now I'm going to go back and I'm going to do the math the way I did it before. If I have 3 -2s, how much charge is that? It's -6. Yeah. So 3 negative 2s is negative 6, which means the irons need to balance that. They need to bring in positive 6. And so if I have 2 irons that need to bring me plus 6, what number needs to go up here? It's got to be 3. Because 3 times 2 is going to give me 6. So then this is the charge coming on the iron. So then I would go in here and I would put the Roman numeral 3. Using the swap and drop method works too. You could reverse that as well. We could say we had Fe2O3, and so to figure out the charges, I'm just, instead of swapping and dropping, I'm going to swap them and erase them. So then this would be a 2 and this would be a 3, but then we have to check. Is oxygen actually 2? Yeah, it is. It's because oxygen is actually 2, then iron is 3. And I put that Roman numeral in here. So whichever method you choose to use, you're good. I'll show you one where it's not quite so clean. Here. I've got FeO. Fe is still iron. We've already seen that iron can have multiple charges. So I'm going to put the brackets down here, and we're going to figure out what that one's got to be. It has to be the other one. Let's prove it. O is going to be oxide. And so now I can do it either way. I'll show you the longer way. If I have FeO, if I have nothing written here, how many of each are being brought? 1. So I've got 1 of U and 1 of U. The charge on oxygen is -2, which means 1 minus 2 is just going to be -2. Which means iron over here has to be bringing +2. These numbers on the bottom have to balance each other. So if I have 1 plus 2, that means the one iron has to be bringing all of that +2 charge. So the charge of that iron has to be +2. So I throw the Roman numeral 2 in here and I'm done. Now the swapping and raising method, if you want to use this one, it's a little different. I'll show you where the snag shows up. If I have FeO, again, if there's nothing written here, they're 1, so we can actually force in that 1. And now if I'm going to swap and raise, I'm going to put the 1 up here, and I'll put the 1 up here. So I'm going to have Fe1O1. And now I look, is this the right charge for oxygen? Does oxygen have a charge of 1? No, it's got a charge of -2. So then if this one should be -2, we're going to multiply this guy by 2, and whatever we do to one, we have to do to the other. Multiply that guy by 2 as well. So then 1 times 2 is 2, and that's the charge on iron. I don't particularly care which way you choose to think about it, but you got to pick one way that makes sense to you and roll with it. Comments, questions, concerns about what I've done here? Okay, then I want you to do these bottom 4. Real quick, show me you can do it. I'll come around and help where needed. And then I'll go through any of them for any of you. Boom. So that's what they should look like. And let's talk about why they are the way they are. So, Evelyn, which way are you doing it? The longer mathy way or this way? Okay. So, tin is going to be SN. This one's P4 or 3 and 4. And then if you're trying to figure out what the charge is on these guys, you're not, I guess 3 and 4 both go into 12. So that's one way to figure out the charge. The other way is, so the way we did it up here was we said, okay, well, there's 3 tins, there's 4 Ps, and we know the charge on P. The charge on P is always going to be the same. So all of the negative ions will only ever have one charge. So this guy's going to be, if you look at the table, it's -3. So the -3 times 4 is -12. And you're right, 3 and 4 both go into 12. So tin's got to bring +12. And there's 3 of them. So if 3 tins are bringing +12 charge, each tin has to be bringing what? What's 12 divided by 3?
4.
It's 4. So then that has to be, the +4 has to be the charge on tin. And so those are the bottom two, iron 2 iodide and nickel 3 sulfide. Questions, comments, concerns on any of those? Okay, so let's go the other way. The other way is easy. Going from the formula to the name is totally trivial. Because the Roman numeral gives you the charge. Because it gives you the charge is exactly the same as what we did yesterday. Totally trivial. So, the formulas of the ionic compounds for the multivalent metals are the same as before, but use the ion charge given by the Roman numeral. Whatever the Roman numeral says, use it. So I'll do one as an example for you guys. I'll do iron 2 phosphide as the example for you guys, this middle one here. Okay, well, iron 2, that iron is Fe. And when it gives you the Roman numeral, that's the charge. So Fe is going to be charged +2. And phosphide is phosphorus, which is a P. And now we go back and look at the table and we say, okay, P has a charge of -3. And now at this stage, you can either do it the long mathy way or you can swap and drop. Does anyone want to see either method, or do we see where we're going to go right away? Let's do it again. I love it. Okay. What's the smallest number, Evelyn, that 2 and 3 go into? You bet. 6 and 6. So how many FEs? If each FE is +2, how many FEs do I need to give me 6? You bet. If each P is 3, how many do I need to give me 6? 2 of them. Fe3P2, and we're done. Crank out the other 5 on your market set, go. Is there anything there anyone would like me to go over? Compare what you got with what I've got up on the screen. There's only one there that's kind of tricky. And that's the manganese 4 oxide. Yeah. Yeah, let's do it. So manganese 4 oxide. So that means I've got Mn with a charge of +4. And I've got O with a charge of -2. Now, Matthew, I saw on your page you like to swap and drop, right? So let's swap and drop. If I do that, I get Mn2O4, but remember the last step in swap and drop is if I can, I must reduce. So are 2 and 4 both divisible by anything? They're both even, so they're both divisible by 2. So you have to divide them both by 2, divide by 2, divide by 2. To put the thing in lowest terms, the 2's are going to give me 1. I don't write 1. And then 4 divided by 2 is 2. Get MnO2. If you're going to swap and drop, you have to remember that last step is if I can divide, I must. So any comments, questions, concerns? We good? Okay. Then the last thing you would have looked at in grade 9 for naming these things would have been these guys down here at the bottom. The polyatomics. So the polyatomic ions are ions that show up as larger groups of elements. And we've got a bunch of tables of these. This is one table, a table of polyatomic ions. If you look at the big periodic table that I gave you, there's another chart down there at the bottom. And on the back, there's another chart. So the big clue when you're working to figure out if you're working with the polyatomic ions or not is, hey, if you have or if you see more than 2 elements, everything we've done up to this point has only had 2 elements to work with. You're just balancing the charge on 2 elements. If you see more than 2 elements, check for polyatomics, always. And you're going to see here there's different names that show up for these things. Yeah, so an example for that is, so like on this particular table, I've got HSO4 right here. The name on this chart is hydrogen sulfate. But if you look on this chart, that same compound, HSO4, has 2 names listed. It has hydrogen sulfate listed, and there's a comma there. It also has bisulfate listed. If it's got multiple names listed, you can use either one, and it'll be fine. So like this one here, hydrogen carbonate, also called bicarbonate. You likely have this in your kitchen if you do any kind of baking. Sodium bicarbonate is called baking soda. But if you have sodium hydrogen carbonate, that's the same thing. Either set of names works. This list here, there's commas all the way down. So let's use the polyatomics, and I'm going to leave you to play. How do we use the polyatomics? The naming and the formula writing are the same. The rules are the same, with one sort of extra snag. Here's what it looks like. I wrote it down before. Let's write it down again. If you see more than 2 types of elements in a formula, look for a polyatomic ion from the chart on your periodic table. For example, I've got MgO. It's one option. 2 elements, no polyatomics. But if I have this guy, MgC2O4, how many elements do I have listed there? There's 3. Every capital letter represents the start of another element. So Mg is 1, C is 1, O is 1. I've got 3 elements. Now I have to go look at the table. What is it? Is it the M and the C? Is it the C and the O? What is it? So let's go take a look. I'm looking for either C2O4 or I'm looking for MgC2. Take a look at the big table. Let me know if you find it, or when you find it, because it's on there. Yeah. It's either going to be the Mg and the C are going to be together, or the C's and the O's are going to be together. So C2O4 or MgC2. You found C2O4. What is it? Oxalate. It's this guy right here. C2O4 is right there, has a charge of -2. So what that means is that in this MgC2O4, this guy right here is your polyatomic ion. And so now, once we figure out which one's the polyatomic ion, we name them. So we name using, someone's listening to music and I can hear it. If you could turn that down, or preferably off, because I'm trying to teach you, that'd be great. We name using the name, or I should say naming rules. Okay, it just went off, thank you. Name using the naming rules from before. And now it's back. Turn off the music. Where's it coming from? I can hear the music, guys. If I'm trying to teach you, you should not be listening to music. Turn it off, please. Okay, so Mg is, what's Mg? Mg is magnesium. Does magnesium have more than one charge? Is it multivalent? Do I have to use a Roman numeral with magnesium? Nope. Magnesium's only going to be +2. And then C2O4, Jedediah found it. It's oxalate. We just use that name as it's written. Oxalate. So that thing there is called magnesium oxalate. That's it. If whatever's out front has multiple charges, you have to use the Roman numerals like we did before. The naming rules haven't changed. The only thing is if we've got a polyatomic, use the polyatomic name. The formula writing is a little bit different. And this is what you're going to take a look for. If you're writing the formula from the name, if the name, and this is where students will get stuck, if the name is not on the periodic table, or you have like 3 names, check the polyatomic ion chart. If the chemical name has 8 or ite at the end, check the polyatomic. If the second name listed does not end in IDE, check the polyatomic ion chart. I'll even add another one. And I've said it before when I was talking about this one, but we'll actually write it here. If there are more than 2 elements in the name, check the chart. So, let's name and formula right here. I've got examples. So these 6 are going to be examples of what we just talked about. I've got NH4 3P. I want to name that thing. Well, there's 3 elements there. There's N's, there's H's, and there's P's. As soon as you see more than 2, check the polyatomic ion chart. The thing and there's a big hint here. The thing that's inside the brackets is going to be your polyatomic ion. So what is the name of NH4? Find it on the chart. Someone's found it already. NH4 is ammonium. And then P is phosphorus. And then when we name the thing, phosphorus becomes phosphide. Yeah. Done. Let's go down. I've got AlOH3. The thing in brackets is the polyatomic ion. So what's OH? It's hydroxide. So Al is aluminum. Does aluminum have multiple charges or only one? It's only got one. So we have aluminum's aluminum, and OH is hydroxide. I'm going to change this next one here. I want it to be, give me a sec. Yeah, instead of that, we're going to do this one. I'm going to go Cu2CR2O7. We're going to change this one to demonstrate something that we haven't seen before. Okay, so there's 3 capital letters there, which means they've got 3 elements. Which group of elements there is going to be the polyatomic ion? Take a look at your chart. Yeah, it's this guy right here. Jedediah's already found it. The Cr2O7 is called dichromate. Which means Cu is what? Copper. But take a look at the periodic table. Does copper have multiple possible charges? Yeah, so we're going to need to throw a Roman numeral in here. Let's figure out what the charge on copper has to be. What's the charge on Cr2O7? So we're having Cu2, and then we've got Cr2O7. What's the charge on Cr2O7? Sorry, Brooke? Is it? Is that what it says? Say it with more authority. Okay, cool. So dichromate's got a charge of -2. And because there's no brackets around the Cr2O7, that means just one of them showed up. Okay? If there's no brackets, that means we just have one of these. So if we have just one bringing -2, and I've got 2 coppers, those 2 coppers need to balance out the -2. So what does the charge on copper here have to be if 2 of them are balancing out the -2? So this guy here, there's 1 Cr2O7, so he's got a charge of -2. The copper is has to bring +2, but there's 2 of them. So then the charge on copper needs to be +1. So then the Roman numeral I have to throw in here is the Roman numeral for 1. Comments, questions, concerns about what I've done here? Okay. You'll have lots of practice to figure out whether or not you get it. Let's go the other way. Let's write the formula from the name. Lithium hydroxide. Lithium is pretty straightforward. Lithium is Li. It's got a charge of +1. What's hydroxide? Now, hydroxide's not a name you're going to find in the elements. It sounds a lot like hydrogen and oxygen. So this is where we're going to go look at the polyatomic ion chart. Hydroxide's right here on this one. It's OH with a charge of -1. So it's OH with a charge of -1. So if lithium's got +1 and OH is -1, then I just need one of each. The formula is just going to be LiOH. And we're done. Next one. Potassium permanganate. Potassium is K. With a charge of +1. Permanganate, that name ends in ATE. So that if it ends in ATE, you immediately go look at the polyatomic ion chart. What the heck is permanganate? So let's take a look. Jedediah thinks it's MnO4. Can we find it? Can someone verify? It's right there in the middle column. Permanganate is MnO4, charge of -1. MnO4, charge of -1. So if this one's +1 and this one's -1, that's just going to be one of each, KMnO4. And we're done. The last one, iron 3 hydrogen sulfide. There's 3 elements listed. So this second piece, the hydrogen sulfide, is going to have to come off the polyatomic ion chart. What is hydrogen sulfide? If it's not on the front table, go look at the back table. What's up, Mr. Keeley? You should be. How is it? Did you look at it? Can we get colored covers? Then can we get colors? Okay. Because I want colors. Okay. We're gonna make students color it too. Or just put tons of graphics on it. Okay, have we found hydrogen sulfide yet? HS. What's the charge on HS? -1. HS with a charge of -1. Iron 3 is Fe plus 3. So, what am I going to have to do to balance these guys out? How many of each am I going to need? Yeah. If we choose to swap and drop, it's going to look like this. The 3 from the iron is going to go down onto the HS. The 1 is going to go down onto the iron. When you're bringing multiple polyatomics, so if I need 3 of HS, we have to put the brackets around HS and put the 3 outside. And then because I only need 1 Fe, I don't have to put the 1. It's going to be Fe and then in brackets HS3. Because I'm not just bringing, if I don't have the brackets, that means I would just be bringing 3 of the S's. I don't want 3 S's, I want 3 of this whole polyatomic ion. So if you're bringing multiple polyatomic ions, the whole ion needs to be inside a set of brackets. And this is it. This is all of the ion naming stuff that we're going to be doing. Something in grade 9 you spent probably a week doing over multiple lessons. We did in 2 days. So this should be review of stuff you looked at last year. There's 10 minutes left in the block. I have got a buttload of practice. We're going to spend a couple days doing it. I'm not going to assign it all today. Yes, Evelyn. Sorry? Yes, so that's why it ends in 10 minutes, not 15. Early blocks because of Abby's Got Talent. Abby's Got Talent. Extended lunch. Okay, so here's what I want you to do. If you flip one page, you should find this. There's a lot on this page, so I'm not even going to assign all of that page. I want you guys, in the next 10 minutes, don't pack up, and then over the weekend as part of your homework, I want you to do both of these charts, but I want you to do ACEs. ACEs is A, but not B. C, but not D. E, but not F. G, but not H. I, but not J. Tell me when I can stop. K. Okay. Every other letter. Odd letters. Odd letters. No, A, C, E. Every other letter starting with A. That's your homework. I've got naming up top, formula writing at the bottom, and everything is mixed together. You're going to have regular, simple ionic ones. You're going to have multivalent ones. You're going to have polyatomic ones. All of it's built in. Take a look at ACEs on those guys, and we'll do some more practice with this stuff next week. That's all I've got for you today on your market cycle.